Hi folks, I apologize for not being here with you. Sometimes I know it's hard to start a unit without me being present or your teacher being present, but I'll do my best. If you have questions, make sure you email them to me. I will have time to answer them hopefully while I'm away. And I'm not sure if this video's fuzzy or if it's my eyeballs that are getting worse. I'm not 100% sure. I keep focusing it, but it doesn't seem to get super clear. Okay, so we're going to dive into inequalities, and I thought this would be a good unit to start while I was away, because the first lesson is really your grade 10 graphing a straight line, and then we're going to add a grade 11 layer onto it by doing the inequalities. So I think the big thing that you have to remember is inequality symbols, greater to, less than. We've used these before. Greater than or equal to, less than or equal to. So if I give you the solution, x has to be less than 4. So that's an inequality. So x has to be less than 4. So there's a ton, an infinite number of values that could satisfy this. If I asked everybody in the classroom to give me a unique solution, you all could do that. Somebody could say 0, somebody could say 3, somebody could say negative 100. All of those make this statement true. Negative 100 is less than 4. 3 is less than 4. So inequalities don't just, equal signs means it equals this one value. Inequality says, hey, it equals all of these values. So it's like a set of answers. So two things when we're graphing linear inequalities is we have a boundary and then we have the shaded region, okay? So again, it feels a little fuzzy, but maybe it'll look better. Maybe it's my eyeballs. The boundary is going to be your line, and then the region is going to be our shaded region. Now, when you graph the boundary, it's like we're going back to grade 10, we're going to graph that line. So it's the equation of the line that we're graphing. When I talk about boundary, that's what we're going to do first. And the shaded region, it's just, does above or below the line make the statement true? Okay, so a couple things when we're graphing boundaries. I found some new pens and I'm not sure if I like them or not. A couple things about boundaries is that if it has the equal to sign, then you're going to graph a solid line. If it doesn't have the equal to sign, we're going to have to graph a dash line, okay? Because anything on that line are not included in the solution. Solid line, it's kind of like the open and closed circles that you learned in grade 9, and maybe you block those out. So a solid line means all the points on that line are included in the solution. And if it's a dash line, that means that they're not. This is really easy to forget about, but that's okay. We'll practice it and we'll get good at it. Okay, so here we go. Straight line equation right here. I know it's not a quadratic because there's no x squared. So I know that this is linear. And linear is just a straight line. So we can do one of two things. We can change this into y equals mx plus b form, where there's just a single line on this side. M represents the slope of the line, and b represents your y-intercept. This should be a reminder of grade 10. You could also graph the x and y intercepts on this and just plot those 2 points if you wanted to do that. That might be easier. You could create a table of values. So there's lots of different ways to graph this line, but it's really up to you how you choose to do it. I think I'm going to rearrange it just because I think working with inequalities is always a good practice. So if I have 4x plus 2y is greater than or equal to 10. Right away, I know that my line is going to be solid. When I graph it, this is telling me I'm going to use a solid line. Okay, nice and easy. I'm going to rearrange it to, well, y on one side and everything on the other. So I'm going to minus 4x from both sides. So I'm going to have 2y is greater than or equal to negative 4x plus 10. I always just like to put my x's first because the x comes first in that. So I tend to do that anyway. I don't want 2y, I just want y. I'm dividing by 2, so every term on the right-hand side has to be divided by 2. I'm dividing by a positive 2, so that has no impact on the inequality. It doesn't change direction. It's only if it's negative that it will change direction. Okay, so now I have my equation here. So this means my y-intercept, y-intercept is 5, and my slope is negative 2 over 1. If it's not a fraction, so if you remember, this means I'm going to go, and write this in a different color. This tells me what I'm doing on my y, so I'm going to go down 2 units, and this is a positive 1, so I'm going to go right 1 unit. So that's why putting it as a fraction is helpful. And again, I'm in my classroom doing this without you guys, so if I'm going too fast, please ask to pause the video so that you know what you're doing and that it makes sense. Okay, so what I'm going to graph right now is I'm just simply going to graph the negative 2 plus 5. I know it's going to be a solid line because it has that. So that's what I'm going to do first. So it's just grade 10 all over again. I'm going to put my increments on. So 2, 4, 6, 8, 10. And it's really important that you have your increments labeled. You can't assume that I'm going to assume that your increments they go up by ones or something like that. So you're going to have to take a moment and label them. You could just put your tens on there if you wanted to, that's fine. But for me, it helps my brain to have all my points labeled. Okay, so first thing I do when I have it in y-intercept form is I'm going to graph the y-intercept. So that's where it crosses the y-intercept. So it crosses the y-intercept at 5. And then my next point, how I get to that, is I'm going to go down 2 units, so 4, 3, and I'm going to go right 1 unit. That's my next point. And then from this point, I go down 2, 1, 2, and right 1. Then I'm going to go down 2 and to the right 1. And as you can see, I'm starting to get the shape of a straight line. You need a couple of points on there, and with any graph, we want to make sure that we label the points. So I got 4 on there. I think that's pretty good. So I'm going to use a ruler and I'm going to draw a straight line. Now, we decided that it would be a solid line because it has the equal to sign. So I'm going to just draw it like I was in grade 10. I need arrows on either end. I need arrows on either end just to indicate that it does go on. This point is 0 and 5. And this point is 1 and 3. Okay, so I've graphed that part. So what I've done is the boundary. Now what I have to do is I have to pick a test point and see if it's true or if it's false. You shade where it's true. So I'm going to pick a nice test point. I'm going to change colors just so I can pick blue here. I'm going to pick 0, 0. That's a nice test point. So the test point that I'm picking, it just has to be either below or above the line. It can be anywhere, but do yourself a favor and don't pick like big numbers or crazy negatives or anything like that. And what we're going to do is we're going to substitute that back into the original inequality, and we're going to check to see if it works. So 4, because we said x was 0, plus 2 times y being 0 is greater than or equal to 10. So I've got 0 plus 0 is greater than or equal to 10. 0 is greater than or equal to 10. That is false. So what I know is that points below the line or points to the left of the line don't work. So that means the points to the right of the line work. Now I would encourage you to use a pencil, as I'm going to, and we're going to shade opposite to where my test point is. I have to test the test point to make sure that it's true or false. We always shade on the side that's true. Now, if you want to double check your math on a test or something like that, where you don't have an answer key or something like that, if this point was false, then maybe you want to test a point in here somewhere, so on the right-hand side of the line. So if I pick, let's pick another test point, just to prove this to be true. Let's do nice and easy. Let's do 4 and 0. And so we're going to have 4 times 4 plus 2 times 0 is greater than or equal to 10. I always substitute it back into the original equation. So I have 16 plus 0 is greater than 10. 16 is greater than 10. So that is true. So I'm going to shade on the side that is true. Now, a couple of quick notes about your shading. It doesn't have to be perfect, but it has to be close to perfect. I don't want to see coloring on this side of the line. And as you can see, I have a little bit going on right there. So I'm probably going to go back in with my eraser and get rid of that. Easy peasy. I probably don't want to go past the line I've drawn. Like this is all still true here, but where does that line continue on to? What if I did this by mistake and scribbled a little bit down here? All of a sudden, this part is incorrect, this part right here. So I tend to stop where my line stops. And the other part is I gotta know what side you shaded. And it doesn't have to be super like dark or anything like that, because I still want to see your graph and your points that you labeled. But it has to be shaded enough that I know which side it is. So that's graphing. So we're going to graph a linear function. We're going to decide if the boundary is dashed or solid. Then we're going to do a test point to the left or to the right of the line. Sometimes I'll say above or below, this being above, that being below. It really, we're picking a test point that's distinctly on either side of the line. And we're only going to shade where it's true. If it's false, it doesn't count. That's my eraser fuzz. Okay. Example number 2. So we're going to do this all again. I'll use a different method for graphing this time. I'm going to do intercept method. So you would have learned these all in grade 10 intro, and if you don't remember them, that's okay as well. You could totally use y equals mx plus b method like I did in the first one, but I just want to show you a different strategy. So first thing I'm going to look at is that doesn't have an equal to sign. So I know I'm going to have a dashed line for my boundary. Okay, so I'm going to do intercepts. So I'm going to find my x-intercept first. And we know that the y value, when we're finding our x-intercept, we know y is equal to 0. That's a true statement all the time. So I've got 10x minus 5 times 0 is greater than 0. So for the x-intercept, we're using an inequality, and that kind of can get confusing sometimes because the x-intercept is a specific point. So if we want to change that, just in this case, to be equal to 0, because we know that it has to be an exact point. So we have 10x minus 0 equals 0. So 10x equals 0 divided by 10, x is equal to 0. Okay, so I know that when x is equal to 0, y is equal to 0. Oh no. Okay, if we find our y-intercept, they're going to be at the exact same place. So if we find our y-intercept, we always know that x is equal to 0 So if we substitute that in, so it'd be 10 times 0 minus 5y is equal to 0. So divide by -5, divide by -5. Y is equal to 0. So it's in the exact same point. So that's not super helpful to us because we need at least 2 points. So x-intercepts and y-intercepts in this case are the same point. So it's not really going to work all that well. So that's how I would tackle it if I was doing x-intercepts. You could go back to your y equals mx plus b if you want to. But while we're here, we might as well do a table of values. So again, these are just strategies from grade 10. You're going to pick the one that works best for your brain and stick with it. I wouldn't flip-flop back and forth between them. I'm just kind of refreshing your brain on different types of graphing. So what I'm going to do is my x-intercept is at 0, 0. I'm going to pick some values to the left and to the right. So -2, -1, 1, and 2. And I'm going to substitute those values into, and I'm using the equal sign because I want these actual points. So if I substitute in 10 times -2 minus 5y equals 0, I've got -20 minus 5y equals 0, so -5y equals 20. If you're not sure what I did there, I added 20 to both sides. I'm going to divide both sides by -5. So it's -4. Okay, so we're going to have to figure out what we're going to do now. You're going to do this for all the table of values. So you're going to change out that -2 and you're going to put a -1 in there. So that'll be -10. So -10 divided by -5 is a -2. And if you're not sure what I'm doing, put it in your calculator, work it through. If I put a +1 in there, that's going to be 10 minus 5y is equal to 0. So -5y is equal to -10. And so y will be a +2 this time. And what do you notice? There's a pattern here. These are going up by a value of 2. And that's your slope. Your slope is 2. So this is going to be a +4. I didn't even really need to do the math on it once I figured out the strategy. But again, if you're doing this on a test or a quiz, or you're not that confident with graphing lines because that wasn't your strong suit, that's okay too. So we can use this whole table of values to graph our boundary. So again, I'm going to put on my increments. And I always like to do every other one. I find when I do every single one, it makes it a little too messy. But it's really up to you, and you have to figure out what works best for your brain and graphing. Okay, so I'm going to graph that table of values. So when x is -2, y is -4. When x is -1, y is -2. We have the 0, 0 already on there. 1 and +2, and 2 and +4. So again, I got about 5 points on there. I'm happy with that. I just have to remember that when I go to graph this one, I need to use a dashed line because there's no equal to sign in the inequality. So I'm going to line up my ruler and I'm going to do a dashed line on it. So again, nothing really different here from grade 10. This is why I thought this would be a good unit for us to do, except I have to be able to see that it's a dashed line. And I know for some people that can be hard to write that down. So now we're going to pick a test point to the left and to the right, or above and below. Doesn't really matter. I can't pick 0, 0 anymore. I've got to pick a point distinctly off the line. So maybe I'll use -2 and +2. So let's try to spell test again. My test point is -2 and +2. And again, I always substitute into the original inequality. The original inequalities. So 10 times -2 minus 5 times 2 is greater than 0. So I have negative 20 minus 10 is greater than 0. So negative 30 is greater than 0. And that is false. So I know that I shouldn't be shading on this side. I should be shading on this side. So just to double check it, because maybe I don't trust my math, I'm going to do 2 and 1. So test point, I'm usually not this terrible at picking test points, but obviously today I am. So we have 20 minus 5 is greater than 0, so 15 is greater than 0. Oops, sorry, you guys can't see that. That's a true statement. So because we shade on the side that's true, we are going to be shading below this line. So again, I'm just going to grab my pencil. And I am going to shade there. Okay, oops, sorry, that's sideways. Again, I'm not really going to go past my line that I've drawn in. Even though it does go on forever, I don't want to mess it up. Anyhow, you can still see that my line is dashed. You can significantly see my shaded area. So, one thing I didn't do was label 2 points. So 0, 0, and we'll go 2 and 4. Almost forgot to label 2 points. So when you're doing a graph, any graph in pre-cal, it should be done on graph paper. And 2 points should always be labeled. And your increments need to be there. That's just kind of like capitals and periods in a sentence. You just always have to do it. You don't have to ask me. You always have to do it. Okay, last page is we're going to create an inequality. So step 1, we got to create that equation of your linear function. And these ones are really poorly shaded. So I'm just going to, graph 1 is shaded below. You can kind of see it, but just so we're all on the same page. Graph 2 is shaded below. Graph 3 is shaded above. And graph 4 is shaded above. Just so we're all on the same page and nobody's terribly confused. You will get a question like this on your test. And I think I talked to you guys about this before. It's only 3 lessons. So we're not going to have a quiz with this one. We are simply going to have a test. Nice thing about test is you have chances to do redo questions. Okay, so you're going back to grade 10. You got to create an equation of a line. Super easy. Super duper easy. I'm going to do it in y equals mx plus b form. And I'm just going to write that up here. Y equals mx plus b. Okay. So this tells me my y-intercept. So looking at this first graph, I see that we crossed the line at -4. So I know what my b is right away. So for graph 1, I know my b is -1. Now I'm going to pick another point on the line, and I'm going to pick 4 and 0, and I'm going to figure out what my slope is. Now remember that slope is the change in y over the change in x. That's what your slope is equal to. So we're just going to count up. Pay attention to your increments here. You're going 1, 2 increments, but each increment counts as 2. So you went up 4, and you're going to go over to the right 4. So my slope, I'm going up 4, so that's a +4, and I'm going to the right 4, so that's also a +4. So I have a slope of 1, and my b is a -4. So that's really great. Something I know already about the inequality I'm going to put in there. The inequality has to not include the equal to sign because it has the dashed line attached to it. So here's the thing. When you are given this graph, you're not picking it, you have to pick a point that's true. And so you need to pick a point. I'll write that here. Pick point from shaded region. Now we do this when we already know what side is shaded. Okay, we do this, like if I ask you to do this question, you're going to get an inequality that is already shaded. So we're going to pick a point inside of there. I'm going to pick 4 and -4. So that's my point here. All right, so what we're going to do is we're going to put it together. We're going to have y, and we're going to have a big fluffy cloud because we don't know what our inequality is right now. We're going to have 1 times x, and I'll just put the x in for now, and then our b is subtract 4. Okay, so the big fluffy cloud is we're figuring out, is it greater than, less than? We know it doesn't have equal signs because it's a dash line. So we're going to put in our 4, -4, that point from the shaded region we picked. So y is -4, big fluffy cloud, because I don't know what it is yet, and 1 times 4 minus 4. So we are going to have -4, big fluffy cloud, is equal to 0. Okay, so is -4 greater or less than 0? And hopefully you are all shouting less than. So I know my inequality, so all I do is take this inequality and I substitute it back up in here. So we're going to have y is less than x minus 4. Now notice I didn't put the 1 in there. If you do choose to put the 1 in, you're perfectly okie dokie to do that. All right, now, okay, that was graph 1. I think we're going to need a piece of paper, or the back side. There's a blank back side here. I'm probably just going to use a piece of paper so that I can go back and forth between the graphs. But let's work harder, not smart. Okay, no. Let's work smarter, not harder here. Do you see another graph that has the exact same line, but only solid as graph 1? And I hope you're all shouting out that graph 4 has the same line, so we know that the slope is 1, and we know that the b is -4. So really all we're doing there is we are finding where we go from here. So I'm going to pop down to graph 4 because we've already created the equation. We already know the slope. We already know the intercept. So all we're doing now is we're going to pick a point from the shaded region, always from the shaded region. And I'm going to pick a nice easy one because it's inside the shaded region. It's 0, 0. So let's go over here. We've got y, big fluffy cloud, a slope of 1 times x minus 4. Oops, sorry, you guys can't see that. So the point we picked was 0, 0. So 0, big fluffy cloud. 1 times 0 is less than 4. Now, we know that this is a solid line, so we know we have to have the equal to sign in here. So we have 0, big fluffy cloud, -4. So what we know is that 0 is greater than or equal to. The equal to comes from it being a solid line, -4. So my equation would be y is greater than or equal to x minus 4. And that would be the equation for graph 4. So sometimes when you look at these, I don't think I would give you a question that would require you to do 4 equations. You'd only have to do it for 1. So we'll go from there. Okay, now let's do graph 2. Okay, so what do I know about graph 2? I know b this time is a +4 because it crosses at a +4, and I'm just going to pick another point. I'll pick this one up here, which is, this one is 4 and 8. So I always do my y first. So I go up 1, 2, which is really 4 units. And I go over 1, 2, so I'm going to the right, so that's another +4. So my slope is 1. Okay, so again, I pick a test point from the shaded region. This one happens to be 0, 0 again, which is delightful. This is a dashed line, so I know that I'm not going to have the equal to sign. So I'm going to have y, big fluffy cloud. Slope is 1, x. And this time it's a positive 4 we're crossing at, so it's a plus 4. I picked point 0, 0 as my test point from the shaded region. So 0, big fluffy cloud. 1 times 0 plus 4. So 0, big fluffy cloud, positive 4. I know that 0 is less than 4. So my equation is going to be y is less than x plus 4. Okay, pretty straightforward. It depends on how comfortable you feel from grade 10 creating equations of lines, but hopefully that'll go okie dokie for you. Okay, and last one is graph 1. Oops, I'm running out of room. Graph 1. So if you notice, graph 2 and graph 1 are the exact same graph. So I know the slope here is 1. I know that the y-intercept is a positive 4. So we're going to pick a point from the shaded region. 0, 0 doesn't work anymore, so I got to pick something in here. I'm going to go 4, 4. Oh, sorry, negative 4, positive 4. And it always has to be in the shaded region. So now when I do my equation, maybe I'll do it in this little tiny area here. So for graph 3, I have y, big fluffy cloud. This is a dash line, so I know I don't have the equal to sign. So I'm going to have 1x plus 4. So I'm going to have positive 4, big fluffy cloud, 1 times negative 4 plus 4. So I'm going to have positive 4, big fluffy cloud. I don't know why I put a comma there, but will forgive me. 0, so we know that it is greater than 0. So my equation is going to be y is greater than, 1x plus 4. I put the 1 in this time, but that's okay. So that's the equation for graph number 3. Okay. I'm sure you're all frantically trying to copy that down. And of course, it wouldn't be full and complete without a word problem. And this is going, again, back to grade 10. You have to create an equation. Okay, so we're looking for all possible combinations of tile and stone that can be used to create a mosaic. The tile costs $2.50 a square foot, and stone costs $6 a kilogram. And the budget for this project is $150. So I know that I have $150 and I can't go over it. I know I can't go over it at all. Okay, so I'm going to create an equation. I'm going to do some variables here. I'm going to say let t equal number of square feet of tile, because I'm introducing some variables and I got to say what they are. And I'm going to say K is kilograms of stone. All right, so what I know is that I cannot go over $150. That's all I have in my wallet. I can't spend any more than that. So we know that this side of the equation has to be less than or equal to $150 because I can't go over it. It can't be greater. So this side has to be less than or equal to $150. So all we're going to do here is we're going to take our 250 times by t, the number of square feet we need, plus the number of kilograms of stone, and it's $6 per kilogram. And we know this amount has to be less than or equal to 150. So we have created our inequality. And I'm just going to write that out a little prettier without the line underneath it because I always think I have to divide. So that's my inequality. So it says solve the problem, and this one is a little bit difficult to solve the problem without a visual representation. So what I'm going to do here is I'm going to actually use K and T intercepts. What we know is that our graph can only exist where square feet are positive and kilograms are positive. If you put them on different axes, it's fine too. So what I want you to do is I want you to find the K-intercept and the T-intercept. So again, if we're looking for the T-intercept, that's just your X-intercept, so we know K has to be 0. I know we talk always about it as X and Y, but it's good sometimes to put different variables on it. You do the exact same thing. So we have 2.5T plus 6 times 0 is less than or equal to 150. Getting my handy dandy calculator out. And so 150 divided by 2.5. So we know that this happens at 60 and 0. Okay, now we're going to do our K-intercept. So that's just your Y-intercept. There's nothing weird or funky there, except we've labeled it a different letter. So if we're looking for our Y-intercept or our K-intercept, we know the other value has to be 0. So we're going to have 2.5 times 0 plus 6K is less than or equal to 150. So 6K is less than or equal to 150. I probably could have left myself a little bit more room because this is tiny. I'm going to divide by 6. Divide by 6. K is less than or equal to 25. All right. So, and notice that I haven't put increments on it after I just finished telling you guys that all graphs in pre-cal need increments and to be done on graph paper. That wasn't very good of me. So this is a really good example of how using intercepts would be helpful. We know that it has an equal to sign, so it's going to be a solid line. There's going to be no arrows because we shouldn't have negative kilograms and we shouldn't have negative time. So we're going to stop at these two endpoints. And let's read this. Tiles have to be less than or equal to 60. So it's anything here. And we know that the kilograms have to be less than 25. So it's anything here. So our shaded region is underneath. And if you wanted to pick a point, if you wanted to put 1, 1 in there, something like that, you're going to see that it is true on that side. So this is the solution, this graph. That's the solving to this question. There's a question about blouses and sweaters or something on one of the tests. So just know that this question is coming back on your test for sure. Okay, so that's it for this lesson. Again, if you need to pause the video or go back, it's also going to be posted on YouTube. It's already there. So if you have any questions, please let me know. Try working through it. You have the answer key. Like I said, I wanted to start here because it was a lot of grade 10 stuff. So I know you guys have a strong foundation. But if you have any questions, please feel free to email me. Go see Ms. Thompson. We will do our best to help. And don't panic. If things aren't working out, don't panic about it. But we do need to keep working forward. We can't just stop. So do the best that you can. Circle any questions. I'll answer them when I'm back or send me an email. Thanks.